Assalamualaikum and hi. My name is Muhammad Adib bin Mohd Saad, metric number 11 DKA 19F1011. Today, I would like to make a presentation experiment 3 about deflection at any section of a determinate beam subjected to point load and distribute load. Apparatus and material that I use in this experiment is scale, marker, ruler, 2 steel ruler. I use bottle and the water as a point load, and book as a UDL load. And also I use the cylinder for the ruler support and the cuboid for the pin support. First step, measure the width and depth of the beam. The width and depth of the beam should be taken at 3 points. First point, second point and 3 points. And then calculate the average of width and depth. Width of beam at the first point is 25 mm. Width of beam at the second point is also 25 mm. Width of beam at the third point is 25 mm. And then measure the depth of the beam. The depth of the beam is 1 mm. At the second point, depth of beam is 1 mm. And measure the depth of the beam at the third point, also 1 mm. So the average of depth and width is 25 mm and depth 1 mm. Second step, put the beam on the support. This cuboid is pin support and this cylinder is a ruler support. Then find the middle of the support using the ruler. Third step, place a suitable load on the beam. For the first test, I will use a point load using a water. First load that I use is 115 gram. Convert into the Newton and I will get 1.47 Newton. Next, put the load into the middle of the beam. Using a ruler, measure the deflection for the first load. Deflection for the first load is 5 mm. Note the value on the table given. Next, increase the load on the beam. For the second load, I will use 300 gram. Next, put the second load into the beam and measure the deflection. The deflection for the second load is 9 mm. Next, increase the load into the third load. The third load is 450 gram. Then, place the third load that is 450 gram into the middle of the beam. and measure the deflection using the ruler. The deflection for the third load is 16 mm. Then increase the load into the fourth load, that is 600 grams. Place the fourth load into the beam. The fourth load is 600 grams and measure the deflection using the ruler. The deflection for the fourth load is 25 mm, and then increase the load to 715 grams, and then put the 715 gram load into the beam and measure the deflection using a ruler. The deflection for the 5 load is 32 mm. When the decreased maximum load is reached, decrease the loading on the beam at the same increase as above until all load is removed from the beam. And calculate the deflection. First, 715 gram load. The measurement of deflection is 35 mm. And then decrease the load until the load is 600 grams. Put the 600 grams into the beam and measure the deflection. The deflection is 26 mm. Then decrease until the load is 415 grams and put the load in the beam and measure the deflection. The deflection is 16 mm. After that, decrease the load until 300 grams and then put in the beam the deflection. The deflection is 10 mm. Lastly, decrease the load until 150 grams. Put into the beam and measure the deflection. The deflection is 7 cm. Then calculate the average of deflection between the first measure and the second measure. Write into the table. Next, repeat the experiment using the UDL load. First, put the UDL load. Next, put the first load into the beam. Before that, measure the first load. The first load is 253 grams. And then put the load into the beam. After that, measure the deflection. The deflection for the first load is 3 mm. After that, increase the load. The second load is 216 grams. And then measure the deflection. Deflection for my second load is 6 mm. Next, add third load. My third load is 228 grams. After that, measure the deflection. Deflection for my third load is 11 mm. Next, add fourth load. My fourth load is 236 gram. And measure the deflection. The deflection is 14 mm. And lastly, add fifth load. My fifth load is 253 gram. And cut and measure the deflection. Deflection for my fifth load is 18 mm. After that, decrease the load until the load is 0. After the all result is taken, calculate the average of the load from the first result and the second result.
Net is result. This table shows width and depth of beam. Note down the result from the experiment. Then calculate the average. The average of width is 25 mm and the average of depth is 1 mm. Next, calculate the moment of inertia of beam specimen. Using the formula and data from the experiment, I get the moment of inertia of beam specimen is 2.08. Next, table 1, point load. First, note down the load that I use in the experiment. The load that I use in the experiment is 1.47 Newton. Next, 2.94 Newton. Third, 4.41 Newton, 5.88 Newton, and 7.35 Newton. Next, write down the del gauge reading when increase and decrease the load. Next, calculate the average for del gauge reading. After that, we need to calculate the data for theoretical mid-span deflection. Next, discussion. First, plot the graph of load versus experiment and theoretical deflection. Second, draw the best fit curve through the plotted point and hence deduct the relationship between the applied load and the resulting mid-span deflection. Third, calculate the modulus of elasticity from the graph obtained, ensuring a linear relationship between load and deflection. First, I calculate the value of slope. Using the formula, I get the value of slope is 0.226. After that, I calculate the value of E. Using the formula given, I get the value of E is 61,117.79. After that, calculate the value for the orientical mid-span deflection using the formula. For the first calculation, I will use my first load, that is 1.47 Newton. And I get the value for the orientical mid-span deflection is 6.5. Using the same formula, I also calculate the orientical mid-span deflection for my second load until my fifth load. Second table is uniformly distributed load. Load for my uniformly distributed load is 2.48, 5.03, 7.3, 9.58, and 12.06. After that, I write all my data that I get from the experiment and I calculate the average of their gauge reading in millimeter. Next is discussion. Number 4. Using the tabulated data, Plot the graph of load versus deflection for load case. 5. Draw the best fit curve through the plotted point and hence deduct the relationship between the applied load and the resulting mid-span deflection. After that, determine the slope of graph. The slope represents the deflection at E. Using the formula, I get the value of slope is 0.66. In conclusion, the more load is applied to the beam, the more displacement occurs. The results from the experiment are not as theoretical due to the occurrence of some errors while running the experiment. Among them is that the eye's position is not 90 degrees when reading the data. Lastly, the error during the calculation also affect the final calculation. That's all from me. Thank you.